Hey students, Mrs. Derby here. We're looking at Unit 6, Lesson 4 today, and so please have your workbook ready. I'm also going to be using a ruler or a straight edge and some very different colored pens or pencils. Colored pencils would be great in case you make a mistake, but just we're going to do some color coding. All right, I love my color coding. Our lesson 4 starts with a notice and a wonder. So maybe your teacher is having you do a notice and wonder to get you started. But some things that we just want to get our mind going on here with some practices that we're going to use right away here on section 4.2. We were introduced to this idea of a radian as a unit of measure, using the radius as a unit of measure around the circle. And we saw that like 1 radian was somewhere around about here-ish, as far as that being the length of the radius. But we're talking about some angles, again, always starting with our x-axis and moving in a counterclockwise direction is how we're measuring angles. And just want you to think about these being equal-sized pieces and how each of these pieces that we have are of equal size. So if this is 1 pi over 6, or just pi over 6, that means if I have 2 of them, this would be twice as much. It would be 2 pi over 6. And adding one more would be a 3 pi over 6. But we also notice that these can be reduced a little bit, right? So like 2 over 6 is the same as 1 over 3. So this pi over 6, when we double it, becomes pi over 3. And when we triple pi over 6 and get 3 pi over 6, well, we can reduce 3 and 6 to be 1 pi over 2, or half of pi. Now that makes sense because now we're starting to think about this being half of pi. If we look at a little bit of a bigger picture, adding another half of pi would give us 2 halves of pi, which is really just 2 over 2, which would reduce to just 1 pi, which is what we saw in lesson 3. So that's good that that's making sense. We would have pi right back here on the other part of the x-axis. And that means if we went the full entire circle, if this is 1 pi for half of a circle, the whole circle would be 2 pi. Now this is back what we were saying in lesson 3, so I'm glad it's making sense so far, but just want to start thinking about how we could count these things according to portions or sixths. Alright, go with me to 4.2, take a deep breath. We're going to construct kind of a master unit circle that we're going to come back to over and over again. It's to the point that you might want to either dog-ear this page. If you don't like dog-earing it, maybe slide a paper clip there, or even like a little post-it sticky note. Okay, because we're going to come back to this page again and again when we're thinking about where these angles are showing up and what we really mean for measures. So, I'm going to start some ideas in the first quadrant, and we're going to start also then comparing them to all the other quadrants around here. So I'm going to grab one of my colored pencils. And I first just want to think about these quadrants. Okay. We have already made some mention about different quadrants, and so I'm going to mark this guy as quadrant 1. And everything in quadrant 1 is positive. X and y coordinates are both positive. Our x's have to move in a positive way, and our y's have to move in a positive way. To the left is quadrant 2, where x's have to move negative to get there, and y's have to move positive to move up above the x-axis. Quadrant 3 has negative x values and negative y values, so a negative happening here. And last but not least, quadrant 4, positive x values negative y's. Now our instructions tell us down below that it wants us to draw and label angles down to pi over 12, all the way to 2 pi. 4 of them have been drawn for us, and there should be a total of 24 angles. We are going to split this pie piece, this whole pie, this whole pizza. Let's call it pizza because we already know that pie is over here. We're going to split this whole pizza into 24 equal pieces. We're going to do this very deliberately using different colored pens to help with me, okay? And we're supposed to label each one. So, let's start with the coordinates of what we do know. These 4 parts of the circle, the main, what we call cardinal points. Okay? Cardinal points like on a compass. Over here, the angle hasn't moved at all, so it's 0 radians. You also know this as 0 degrees. We have said a few times before that by the time it gets to half of a circle, it has to have gone pi radians. Now I'm going to also mark these in degrees too, just in case it's a little bit easier for you to make that association with degrees. Okay. 180 degrees is pi. Half of 180 degrees up here is 90 degrees. And if this is pi, going from here all the way to here, that is only halfway there, so this is pi over 2, or half of pi. Now we're going to be doing a lot of this counting. If this is 0, pi over 2. If this is a half of a pi, 1 pi over 2. This is 2 halves of pi, or 1 pi. So we have 1 pi over 2, 2 pi's over 2, 3 pi over 2. That's 270 degrees, by the way. And then all the way around the circle, we would have 4 pi over 2, but 4 over 2 is 2 pi. Okay. In that same way that we just did that division, we're going to keep on doing that, counting all the way around. Okay. Now I'm going to draw this in the first quadrant first, and then we're going to extend them to all these other lines as we go out here. So watch my color coding as we go through this. Okay. I'm going to pick up a new color, and I'm going to work at the halfway point. Halfway between these two is right about here. Okay. A way to know where the halfway point is. They have this angle drawn for us. I'm actually going to trace this in my color that I'm using. I'm using blue, so I'm going to trace it in blue. It is exactly even across here. It is also in our other quadrants. I'm connecting these points because now you may have noticed we've made a square going on here. I'm going to draw some lines exactly to the corners of those squares, and I'm going to do it across all of our quadrants right now. So we have now split this pizza, or this pizza pie that was into quarters in green. Now we've split each of those quarters in half, and now we have eighths. Okay? So we have 8 even pieces of pie in our whole circle. Well, if from here to here was pi over 2, and our point that we just marked here is exactly halfway in between that, we need half of pi over 2. And half of pi over 2 is pi over 4. It's a fourth of pi. So we're going to label this as pi over 4. And now we're going to go around that circle and label it as portions of 4. Okay, so we have 1 pi over 4, 2 pi over 4, but 2 pi over 4 is the same as pi over 2. Now I'm not going to keep on marking things like that. I think we have this idea that we have equivalent values, like this 4 pi over 2, and this 2 pi over 6, and 3 pi over 6. Okay, so I'm going to say it, but I'm not going to always write them like this. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, they've already marked it for us. 4 pi over 4, but it's already marked as pi. That makes this 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. These are at 45-degree angles. Okay. I'm not going to mark them all the way around the circle, but we could mark them as like 135, and I think that's 225. So we could just keep on adding 45s, but just know that these ones in blue are 45-degree angles. Changing colors. I'm going to go to orange. Let's now just work in quadrant 1 here. Okay. They have this thing in as 13 pi over 12. I'd like you to use your straight edge and just draw that same angle continued into quadrant 1. So that's going to be my orange guy there. These orange ones are the smallest that we're going to get. Pi over 12 is what that is. So somewhere between here and there, let's see, if we were to put this in terms of pi's over 12, we would need to have 3 pi over 12 to get there, to reduce it to pi over 4, because 3 goes into 12 4 times evenly. So I have 1 pi over 12, and then I jump to 3 pi over 12. There should be something in between there. Okay. I'm going to change my colors, but I'm going to come back to this orange. Trying for the best way to do this. It's always tough. So we've got that guy. Yeah, I'm going to come back to him. I'm going to change to a color I haven't used yet, and I haven't used purple. With my purple, I want to draw a angle in here right between pi over 12 and pi over 4. And I want to continue it also into quadrant 3. Okay, so do your best to kind of estimate something right in between there. Try to make it as even as you can. And now we're almost complete because we're already seeing I'm just going to need one more slice up here. Okay, so hang with me while we're working with this stuff in purple. Use that, use this. Nice. Okay. While I'm working with purple, if this was 1 pi over 12, this would be 2 pi over 12. But we can reduce 2 over 12 to be pi over 6. You may know this better as a 30-degree angle. That 30-degree angle that we're seeing there when we keep on moving, I see that we now have pi over 4. Right, so we had 12 pi, or 2 pi over 12, 3 pi over 12, 4 pi over 12, which is the same as pi over 3. This up here is a 60-degree angle. So I'm going to keep my same colored pen, and I'm going to draw this angle not only in my purple, but I'm also going to continue it here into quadrant 3, just like we've been doing with all of our others. Now I'm going to go back to my orange pen, because I see there's just one more angle that we need to place in between here. And again, we're just going to kind of roughly estimate as close as we can to getting it even, split in half, like that. That looks pretty good. Nice. All right, so we're getting our 12ths going on here. That same kind of 12th that we just drew here in quadrants 1 and 3. As long as we still have our orange pen with us, let's draw the rest of these guys. We want to draw something roughly the same in quadrants 2 and 4. Now, if you need help with where to put that, you can just follow that dashed line right across from the one we had drawn before. We're going to start seeing a lot of these we can connect them as like rectangles in between. Keep that same orange pen, because just like we had it up here in quadrants 1 and 2 at 30 degrees, we also want to think about that at about 30 degrees the other direction, 30 degrees below the x-axis. Again, if you need to kind of put a little dashed line like, hey, it's going to hit there, and right about hit there, and then you can connect those dots. That's kind of a nice way to do it as well, going right through the center. We almost have all of our lines drawn. So I'm going to go back to my purple pen, the one that I did here at this pi over 6 and pi over 3 at 30 degrees and 60 degrees. I see that I need some coordinating points down here. And look at this one. This one's already drawn for us. We just haven't color coded it. This 5 pi over 3, line up your straight edge and continue that same line when you're color coding into quadrant 2. And then our last line that we're going to draw is kind of splitting that difference right in that big gap that you see there. All right. So believe it or not, we now have this split into 24 equal parts. Now we just need to go around and label each of them. Now I'm going to be switching between all of my different colored pens. My orange, my purple, oh, I guess just those two. Right, because I already labeled all of my blue ones, and I already labeled all my green ones. Cool. All right. We're just going to count in 12ths of pi. So 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. That would make this 5 pi over 12. Then 6 pi over 12. 7 pi over 12. Our next one is 8 pi over 12, but I notice it's in a different color. And actually that's my signal there to tell me I can reduce 8 and 12. 4 goes into each of those evenly. So we could call that 2 pi over 3. We're going to notice some other patterns happening there. So I had 8 pi over 12, 9 pi over 12, 10 pi over 12. But again, I see that that angle is in a different color. So 10 over 12 can be reduced. They can each be cut in half to be 5 pi over 6. And last but not least, 11 pi over 12. Can't reduce that. He's still in my same color that I'm using. So, we've done that whole first half of the unit circle, counting by pi over 12 sections, but then also reducing every time we had a chance. If we think about the ones that we have drawn in at the 30-degree or the 60-degree lines. We're really counting those as pi's over 6 and pi's over 3, right? So if you connect these two that we've now done here, we had a pi over 3. That would be 1 pi over 3 to get here, a third of pi, so a third of the top half of our circle. There's 1/3 of it, and then over here is 2/3 of it, and over here would be 3/3 of it. And so maybe you're already thinking about counting in thirds, that this down here would be 4/3 of it. Now make sure that you're connecting that kind of same point along the same line here, that we're counting in thirds of pi. If you need to, you can connect those squares to keep you on track. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, that checks out because they already had it pre-written for us. 6 pi over 3, but 6 divided by 3 is 2, and we're right back to 2 pi. In the same way, each of these smaller ones, that pi over 3 now split in half, pi over 6 at 30 degrees, each of these also connects in a square, or a rectangle. Gotta think like a geometry teacher. And now we can start making some connections across here, because this was 1 pi over 6, 2 pi over 6, 3 pi over 6, but 3 divided by 6 is half, so that's why we have pi over 2. 4 pi over 6, 5 pi over 6, right? Even here would be 6 pi over 6, but 6 over 6 is the same as 1, so that would just equal pi. That makes this guy down here 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, but 10 and 6 can be reduced. And that means this guy has to be 11 pi over 6. Whew. We're almost done. Switch to whatever your color you're using for your smallest angle. Remember the ones that we were dividing up by 12s? We have just a couple more to label. Again, we're back to counting to pi over 12. So starting here, 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. We already labeled that. 6 pi over 12, 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, 12 pi over 12, 13 pi over 12. There's our checkpoint. We know we got it right. 14 pi over 12, 15 pi over 12, 16 pi over 12, 17 pi over 12. This can't be reduced. That's why we have to write it in here. 18 pi over 12 could be reduced to 3 pi over 2. 19 pi over 12 cannot be reduced. 19 pi over 12. 20 pi over 12. 21 pi over 12. 22 pi over 12. 23 pi over 12. And then as soon as we get to that 24th pi over 12, 24 divided by 12 is 2. We didn't need a whole lot of numbers to start with. In fact, all we needed to know is that 0 all the way around to 2 pi. That's all we needed to know to begin with. Everything else was just splitting it in half, and then splitting the half in half, and splitting that quarter into half to make it eighths, and splitting all of these pieces over and over and over again. Okay? Keep this place tabbed. You're going to use it again and again.